Now you've seen me use lists a couple of times in some other videos now, so I've sort of introduced you to the basics, but essentially a list is probably the most popular data structure that exists in Python. And a data structure is a place where you can put multiple pieces of data in one single location. So if I make a variable, call it fruits, which is the one I used before, and if I put square brackets, this is what defines a list. So all the different types of brackets have different meanings. Square brackets mean a list. And then instead of having just a single string or a single integer, I can have multiple. So I can have apple, banana, orange, and pear. So I've got 4 bits of fruit in my list. And I'm going to show you a lot of the different things you can do with it. I'll go through the most basic in the first couple of minutes, but then I'm going to show you a lot more because lists are going to be used loads in different algorithms that you're going to make. So it's important you know some of the main things you could do with a list. So the first thing is simply to print it. If I print fruits, so you can see how it outputs as the entire list look. So apple, banana, orange, and pear all together. So it shows you the entirety of the list. However, you can print just a single location in the list. But this is coming back to the loops, and this might not print out what you think. When I print fruits at position 1, that shows me banana. But you need to remember, just like in the loops, Python starts counting at 0. So apple is in location 0 in my list. So if I'm to print that, it prints out apple, but position 1 prints out banana. So you can print out the entire list, you can print out a certain position. It's also worth noting that you don't have to just have strings. Lists can have different values in, and they still work fine. So you can have values of different types. Now I'll do it in a different video, but you can even have lists inside a list. But just know that that's true for now, and we'll come on to it later. Okay, so let's go back to where this was all fruit. So you can print out items from the list or the entire list. We can add to the list. So if I do fruits.add, append, it's because I just said add. If I append to the list, so I'll do cherry. When I then print the entire list out, you'll notice that we've now got a new item at the end. So when you do a dot append, which is probably one of the most common ways to add to the list, that always adds to the end of the list. That's what append means. So append means add to the end. You can remove as well. So dot append means add to. So what I'll do is I'll leave them on so you can see them, and then I'll comment them out. So obviously notice when I comment, that's never going to run. So if I run the code, cherry never got added to my list. So my list is still 4 items. It's just important you know that. Comments obviously are not run, so otherwise some other bits might not make sense. So I can remove from my list. So fruits.remove, and then you've got to find something to remove. So I'm going to remove apple, and you put it in normal brackets. Look, so it's only square brackets for the list itself, and when you're indexing the list, which I did earlier, that's where I was doing print fruits square brackets 1. So that's indexing, where you index a certain position. So I can append, I can remove. So then when I print my list, you can see apple's no longer there. So I can remove from my list. I'll comment that one out as well. Let's show you some more things you can do. So we can change a specific position. So what we could do is fruits at position 2. So that's orange, look, 0, 1, 2 is now equal to cherry. So just like when we changed a variable in the past, we can change a certain instance. So look, cherry is now in position 2 in my list, and orange is completely gone. Now just notice the difference. If I do this, it's not going to break my code, but my whole list is gone. So this list was stored in the variable fruits, but I've overwritten it here with the word cherry, so my list is gone. So just be careful of that. So that's saying just whatever's in position 2 becomes cherry. So I can change just a certain location to be something new. I can loop through my list. I think I showed you this before, but I could do for item in list fruits, print item. So then look, that's printing them one at a time. And then this here at the bottom is just what's on line 10 at the minute, where it's printing the entirety. So I can loop through my list. There's lots more you can do, but I'll just go over some of the main ones. I could use membership operations again to do a quick check if something exists. So I could do if Apple in, so that's the membership operator I taught you a while ago. So if that is in fruits, then I could print something like Apple exists in list. So you can see that's printed out because Apple does exist. If I change that to cherry, it's not running because cherry doesn't exist in the list. So you can do not in as well. So you've got in and not in. So you can do that to check if something's a member of the list. You can delete. I could do del fruits at position 1. Then when I run it, you can see position 1, which was banana 0, 1. That's gone. So that's another way to get rid of something from a list. I could do fruits.clear, which clears the list. So it's still a list, but it's empty. So clear means empty the list out. A couple more and then I'll stop. You could find the length of the list. So I could do len. We use len a lot. So I could find the length of the list. You can find lengths of strings. So see how many characters in a word, things like that. So you can see it shows me there's 4 items in my list. What else? I could do dot count. That might be quite useful. So I could do fruits dot count. I'll print this out. Fruits dot count. And I'll go for banana. And it shows me there's 1 banana in there. If I were to add another, you can see it's found both. So you can count what's in the list. Move that, put 1. I could index something. So I could find out where something exists in the list if it's in there. So I could do fruits.index. Now I'll go for banana just to show you how this works as well. So it's saying find the position of banana in the list. So banana's at 0, position 1. It's obviously also at position 3, but this stops when it's found 1. So it will only find the first index of something in the list. If I do something that doesn't exist in the list, this errors. Okay, so you need to maybe do this inside a membership where you've said if something is in the list, then find out the position. So otherwise you get an error. But that will find out the position of something in the list. And the last 2 things to show you just dead quick are if I was to print fruits, there are 2 methods that are sometimes useful where you can either reverse or sort out the list. So if I did fruits dot reverse, that means reverse what's in the list. So that's a little method that's going to run. And when I run it, because on them print out the fruits, you'll notice that pair was at the end is now at the beginning, and it's swapped the order. The other thing you can do instead of reverse is sort. Then when I run it, it's sorted alphabetically, so you can see both bananas are next to each other. There's a 0, 1, 2, 3, 4. So that is a lot of the main things that you would do with lists. There are more, but I think that will have you covered for the vast majority of the first, 50 hours of your coding life. I can't see any reason you need to use more than all of that. So lists are a really useful data structure that you will use time and time again. And it's important to know you can pretty much do anything you want to. It's just knowing the right syntax of whether you just want to remove something, you want to swap something, you want to find where it is, you want to see how many items you've got in the list, whatever it is, we've got syntax for it. It's just about learning the syntax.